doing for these notes is chapter 22 when we're comparing two proportions. What's nice is you've already learned all the processes. We just have to apply them now to a two proportions, okay? So what's going to happen is a sampling distribution. Sometimes we're going to have to find the difference between the two proportions. So this is when we're going to be comparing two sets of proportions, which makes sense. That's why there's two of them, and it's the difference comparing two sets. A lot of times you're going to be subtracting the means. Actually, I don't think we're going to be adding the means for a while if we do. So we will subtract the means, which is not a big deal because if you remember from previous chapters, we learned that mean will kind of do whatever you tell it to do. You can add it, multiply it, subtract it, and it will just do what it's told to do. Okay? So with standard deviation, though, it's a little different. One thing before we get into standard deviation is you're going to have different types of proportions. You can call them P1 and P2, which means there would be a Q1 and Q2, but we have to know what the 1s are and what the 2s are. What you could also do is do the proportion who won the first time versus the proportion who won the second time. So P1 would be won the first time, P2 would be won the second time. And when I do the examples, I'm going to write it out as the notation so that I don't have to write a sentence stating what it is. Okay, so when we do the standard deviation, well, if you remember back when we did standard deviations before, standard deviation, even if you're subtracting, you're still adding the variances. So the standard deviation is the square root of P1 Q1 over N1 plus P2 Q2 over N2. And it's always plus, right? And we should hopefully remember that. Okay, so there are a couple conditions. Randomization, that's the same. Is it random? That's the same as what we've done. So is it random? And again, usually it's going to state that it's random. 10%, is it less than 10% of population? Same rule. Success failure, that's the NP, so it's going to have to be N1, P1 is greater than 10, N1, Q1 is greater than 10, and then you have to do the same thing for the other sets of data. So you have to check both. You can't just check one. Okay? And then the last one is independent groups. This is only going to work if the groups are independent from each other. Okay? So they're not related to each other. Independent groups from each other. So independent from each other. Okay? So confidence interval really is kind of the same thing. It's based on, first thing you have to know is that after you calculate the confidence interval, you have to remember that the mean is based on the difference. So the confidence interval is going to be the mean when you're going to subtract them. And then you're going to use your z-score, your critical point, and then the standard deviation, which is the same thing as what we had up above. Way up there, there it is. Okay? So it's that same thing down below. So P1 Q1 over N1 plus P2 Q2 over N2. And again, remember when we add or subtract this, it's subtracting from the mean, and our mean is gotten by subtracting P1 minus P2. So we're going to add and subtract that right here, the standard error. We're going to add that and subtract that from our mean. And that's how we'll find it. Okay? So before we go on to pooling and the next type of problems, I actually wanted to do an example. So the first example is an example of the textbook. I'm going to do differently than what the textbook asked, just so that we have one good example. So go ahead and hit pause so you can copy it down, or you can go back and copy it down later. Okay? So the first thing we need to do is we're always going to check the assumptions. So a president candidate fears that there's a problem with women voters, that he has a problem with them, not that there's a problem with them. His staff plans to run a poll, 300 men, 300 women, asking if it's a favorable oppression. there is a positive image for 59% of men and 53% of men. So first of all, is it random? Yes, it's random. Second of all, 300 men and 300 women is less than 10% of the population. We're good there. These groups are independent. Man and woman don't rely on each other for what they think. And then the last one, success, failure. 59% and 53% means that there's going to be more. And usually we'll show those steps if we're doing the full-on hypothesis testing, but we're not going to do that for here. And eventually what we'll do is maybe we'll start practicing a way that you can summarize it all in a sentence or two. All right, so the first thing we need to do is we need to find the mean. And again, we're trying to find out if there's a difference. So we're going to find out the difference from P1 minus, and I wasn't going to say P1, I was going to say P men, the probability that men minus the probability of women, which is 59 minus 53. So the mean is 6%, okay? All right, the next thing we need to do is do the standard deviation, okay? So the standard deviation, let's do the men first. So that's going to be 0.59 times 0.41 divided by 300, because there was 300 men. Let me zoom in so you can see that. Okay. Plus, let's do the women in the second one. 0.53 times 0.47 divided by 300. And let's get a calculator to see what that is. Okay, and so when we plug it in, it's 0.04. So our standard deviation is 0.04. Okay? So another thing that we'll have to be able to do is draw a curve. So let's go ahead and set up our normal curve. So the mean is the difference, which is 0.06. And then we're going to do 3 standard deviations to the right, 3 to the left. My curve's kind of off, but that's okay. So 0.06 minus 0.04. Do it again. If you notice now I'm going to get to negatives, but that's okay. We can have that. Oops, not 8, but 6. I'm not making any mistakes. I'm kind of rushed. Okay, and so now, again, you know the standard information is that 68% is between here, 95%, and then 97%. Okay? And then another thing that you'll have to do is let's just do the confidence interval to show that it all kind of works the same. Well, we already had our standard deviation, so let's do a 95% confidence interval. So 95% gives me a z, a critical point of 1.96. So 1.96 times 0.04. So 0.0784. So now my confidence interval is I'm going to add this and subtract this from the mean. So 0.06 plus or minus that. So it's between negative 0.184% and 0.1384%. And so the negative would just mean that if you look at it, the only way I could get a negative number is if women are in more favor of him than men. And so that's why you can actually have a negative number. Usually we don't get negative numbers, or we kind of disregard them as percents. But because we're talking about the difference, if we got a negative number here, a negative percent here, it just means that women are more favorable than men. Okay? All right, so hopefully that helps. Okay, so going back to our notes, the next thing is sometimes you're going to have to pool things, and pooling happens when you combine counts, combining counts to get an overall proportion. You are going to pool things when two different groups that you're comparing come from the same population. So when the two groups come from the same population, that's when you're going to pool. Okay, and for pooling, it's just kind of what it sounds like, is that you're going to add the successes from one group plus the successes of another group. Oops, that's supposed to be 2. And then you're going to add your total number of successes, so N1 plus N2, okay? When you do a 2 proportion z-test, which is one that has to be pooled, I'm going to write it down and then talk about it. Okay, so a 2 proportion z-test, you're always going to subtract them because your null hypothesis is that they're the same, so that means they're equal. But we want to be able to compare it to 0. So that's why I subtracted them. Because if I had P1 equals P2, all I would have to do is subtract P2 to get 0. So we're always going to set the null hypothesis equal to 0 so that we can compare and see what the difference is. Okay? When we pool them, it's going to be all the successes and all the failures pooled over your first set of numbers, however many were in the first set. And then all your successes and all your failures pooled over the number of in the second group. Okay? All right, so we have another example. So if you want to copy it down, go ahead and pause. But it's just talking about people that have cardiac arrest or cardiac disease, and they followed them for 4 years, and they're trying to see if those with depression issues die more frequently. Okay? So the first thing we want to do, we're not going to go through the whole process, but we are going to do some of it. And the first one we're going to want to do is write the null hypothesis, which is P with the no depression minus P with the depression is the same. They're equal. So no depression and depression would give us the same results. So that means our alternative would be no depression minus depression. There is a difference, so it would be greater than 0. All right, because there's a difference, so there would be an issue. Okay? All right, so the next thing, we're going to check our assumptions. Usually we're going to write it down, but for the sake of this time, I don't want to spend your whole night doing this. Is this random? Yes. They found the 450 people, and then they watched them from there. 450 is less than 10%. Success failure works. Now, if you notice, though, these groups, they come from the same pool of the population because they all came from 450 people. So this is an example where we are going to have to pool our results, okay? And so, let's see. Oops, and I think I made a mistake on this. I wrote it's supposed to actually be less than. So none minus the dependent should be less than 0, because if there's more depression, then we want to know that. So that's if there was more depression, it would be a negative number. Sorry about that. Okay, so what we need to do is we need to find our standard deviation. Our mean, we're going to compare it to 0 because we're subtracting them, and so we're going to compare it to 0, okay? But it's our standard deviation. So what we need to do is let's pull it first. So the proportion of none is, what was it? 67 out of 361. So that means the Q of none, no depression, is 294 over 361. And so the probability with depression is 26 out of 89. And then the probability of them not doing, or the Q of that, is 63 over 89. Okay? All right, so when we do this, if you want to plug in the percents, you can. When I look in the textbooks, they write it in as the fractions to make sure. Okay, so go ahead and try and plug it in. I'm going to plug it in, and then it'll be up there in just a second. One thing that I didn't talk about real quick is that you have to pool them, so you have to add these up and put it here, and then you add these up and put them here. And so it's the pooled P's times the pooled Q's over 361, and the pooled P's over the pooled Q's over 89. So what I just did real quick is I found out what the pooled were right here, and instead of typing it in twice, I took that answer divided by 361 plus answer divided by 89. That way it took that answer and put it in both places. So our standard deviation is 0.048, okay? And then now what we need to do is we're going to see how often we'll reject the null, okay? And so I'm just going to kind of draw my little rough draft, my rough graph. My mean was 0. And I need to find out where this would happen, what would happen. So right now, what it is it's going to be the probability of no minus the probability of dependent. Okay? And so no depression, and I think I might have wrote those backwards. Hold on. Okay, so sorry I didn't. No depression is 0.186 minus 0.292. And so the difference of these two is negative 1065. So I need to see how rare that is right there. And so that's over here. So I'm going to do my normal distribution. I'm going to keep that negative number, negative 0.065, 0.048. And I find that that's a p-value of 0.013. So that's saying only 1.3% of the time we could get the same results. And so because that is such a small number, we're going to reject our null hypothesis. So we're not going to say that they're the same, that depression and non-depression has the same rate of death, okay? So as you can see, it's kind of the same process. This right here, this pooled part, I think is going to be the most difficult, and it's not that it's difficult, it's just a little time-consuming, and you have to use your calculator. So remember to go back and submit a note or a comment or a question on the blob, and then that way I can get those answers ready for you, okay? All right, thank you. Sorry, this one was a long one.